All right, everybody, we're back for another set of formula and composition calculations. But again, the idea of an empirical formula being the relative number of atoms of the different elements in a compound with the smallest set of whole number integers. And we'll be using the idea of the mole. If an element or compound has a mass of so many atomic mass units, then 1 mole of the same element or compound has a mass the same number of grams. The first problem, 15.00 gram sample of an unstable hydrated salt, sodium sulfate, was found to contain 7.05 grams of water. What is the empirical formula of the salt plan? We're going to find the grams of sodium sulfate, the moles of sodium sulfate in water, and then go for the whole number ratio. We'll need the molecular weights of both compounds, so 2 times the atomic mass of sodium plus the mass of sulfur, and 4 times the mass of oxygen will give us the molecular weight for sodium sulfate, which here 142.05 atomic mass units, which means, of course, that there will be that number of grams per mole of that compound. Similarly with water, we come up with 18.02 atomic mass units or grams per mole. Using those numbers that we just calculated and subtracting 7.05 representing the grams of water from the amount of salt that we started with, we come up with 7.95 grams of sodium sulfate being present initially. Divide that by the number of grams per mole of sodium sulfate to come up with 0.56 moles of sodium sulfate, 0.39 moles of water. Similarly, divide the 0.56 into 0.39. We come up with 7, and that gives us the empirical formula of the hydrated salt as Na2SO4.7H2O. And that's the first problem. Next problem is going to be a quick one. 2.5 gram sample of uranium was heated in air. The resulting oxide weighed 2.949 grams. What's the empirical formula of the oxide? We subtract the two numbers and find 0.449 grams of oxygen was present in the oxide. Divide both of those numbers, the weight of uranium by number of grams per mole. Same thing for the oxygen. Come up with 0.015 moles of uranium and 0.281 moles of oxygen. Dividing the smaller into the larger, we come up with 2.66 or 2 2/3 or 8/3. And so what I did was just say, hey, multiply 3. So we come up with an empirical formula of U3O8. And that's the problem. Problem number 3. A 1.367 gram sample of an organic compound was combusted in air to give 3.002 grams CO2 and 1.640 grams of H2O. If the compound contains only carbon, hydrogen, oxygen, what is the empirical formula? What we're going to do, find the grams of carbon, hydrogen, oxygen, then the moles of each, and then the whole number ratio. We need the molecular weights of our compound. So CO2 has a molecular weight of 44.009 atomic mass units, and the percentage of carbon in that compound is the weight of carbon divided by the molecular weight of the entire compound. We get 27.92 grams or percent of carbon, and we do the same thing for hydrogen and come up with 11.19% hydrogen in water. So the number of grams of carbon initially 0.8192, hydrogen calculating the same way 0.1853, and 0.346 grams of oxygen present. Using those numbers, we can now find the moles present of each of the different elements in the compound. We'll take the 0.8192 grams of carbon divided by the molecular weight of carbon and come up with 0.0682 moles of carbon. Similarly, we'll calculate 0.182 moles of hydrogen, 0.228 moles of oxygen, the 0.228 being the smaller number there. We'll divide that into the moles for carbon and hydrogen, come up with 3 for carbon and 8 for hydrogen, giving C3H8HO.